Okay, we have a moments question. We're going to have to find RB and RA. The first thing to do is put in reaction forces. Now at B, it's a roller. So that means the reaction must be at 90 degrees to the surface. If there's any sideways force, it would just roll. So it must be at 90 degrees to the surface. A is a hinge. It can support a vertical force and it can support a horizontal force. Now, if you get the directions wrong, you'll just get a negative answer and you can just flip the direction at the end. Okay. Number one, put in the reaction forces. Now, we have to deal with a UDL in this question. So for every meter, you get 4.5 kilonewtons. Okay, the thing's 3 meters long, so the UDL will be 3 times 4.5 kilonewtons. And that gives us a point load of 6.75 kilonewtons. So instead of thinking of this UDL, we'll just have a 6.75 kilonewton point load. The 8 kilonewtons at 70 degrees, when I'm doing the moments, I can split it into the vertical components. So that is 8 sine 70 degrees. Now the 70 is the horizontal, so that's correct. Later on, we will need the 8 cos 70, the horizontal component of that 8 kilonewton force. Okay, so that's us set up, ready to go. The next step is to do the sum of the moments about A, and that will give us the reaction. Okay. So RB is 1.5 away. It's going anti-clockwise, so it's minus. Okay. The UDL, the point load, the 6.75, is 1.5 plus 0.75 away. So, and it's positive. It's going in the clockwise direction. So it's 6.75 times its distance, which is 2.25. Okay. And the last force is the 8 sine 70. And it is 3 meters away from A. So that's times 3. Okay, it's positive to try to spin the thing in the clockwise direction. The 8 cos 70, it's pushing in. Right? A moment is a turning effect. The 8 cos 70 is not causing a moment about A. Okay, it's just pushing. Okay, so if we then do a line of working and then solve this, we find RB is 37.8 kilonewtons. 37.8 kilonewtons. We're now ready to do the sum of the forces in the vertical direction equals 0. Okay. So we've got AB, it's gone down the way, so it's negative. We have got the 8 sine 70 also going down the way, so it's also negative. We've got the point load instead of the UDL, which is going down the way, so surprise, surprise, it's negative. And we've got RB going up the way, so it's positive, so it's 37.8. Rearrange that and you'll find that A is 36.9 kilonewtons. AB, sorry, not A. So AB is 36.9. So there, 36.9. It's positive, so that means the direction I've drawn this arrow in is correct. So AB is pushing down on the system. Next step is the sum of the forces in the horizontal direction equals 0. Right? So we've got AH in the horizontal direction, it's going in the positive direction, so it's positive. Right? The 8 cos 70 is pushing in the negative direction, and that will equal 0. So AH equals 8 cos 70, and that equals 2.7 kilonewtons. Last stage, so we've got AH is 2.7 kilonewtons. If we add on to that the AB, which is 36.9 kilonewtons. Okay, so there is force A. So if we use Pythagoras, 2.7 squared, or the square root of 2.7 squared plus 36.9 squared, we find that A equals 37 kilonewtons. We need to find theta. So theta is tan to the negative 1 of the opposite over the adjacent. So when you do that, you find that theta equals 86 degrees. Okay? Step by step, and it's not too bad. Right? Start off by putting on the reaction forces, in this case RB, AB, and AH. The UDL is dealt by changing it into the equivalent point load. Make sure any angles in the forces are to the horizontal, then the vertical components will be sine, the horizontal components will be cosine. Okay. After that, take moments about the hinge. In this case, it's A. Right? The reaction at B on the roller has got to be at right angles. Okay. After you've done it, find RB, sum the force in the vertical, and you'll get the vertical component of A, sum the force in horizontal, and you'll get the horizontal component of A. And then use Pythagoras and SOHCAHTOA to find the last two parts.